Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course, Chemical Bonding. Today we will begin with lecture 37 from the course, but make sure you watch the previous ones before viewing this one. In the last lecture, we learned about writing the electronic configuration for various molecules. And now in this lecture, what we learned was how we are going to calculate the bond order and also a prediction of the magnetic behavior, the diamagnetic and the paramagnetic, based upon the number of unpaired electrons. Now there in the lecture I told you that this is going to be a very time consuming process when we will have to write the whole electronic configuration for the molecule and then calculate the bond order as well as predict whether it is going to be paramagnetic or diamagnetic. So here in this lecture I will be giving you two tricks. The first trick is going to be for calculating the bond order and the second one for prediction of the magnetic behavior, and this is going to be really helpful for you people in your competitive exams where you have to do the questions in the shortest time possible. So the first trick we have is to find the bond order. Now to calculate the bond order, we know now that bond order is going to be NB minus NA divided by 2, where NB is the number of electrons in the bonding molecular orbitals, NA is the number of electrons in the anti-bonding molecular orbitals. And if we have to calculate the bond order this way, it is going to be really time consuming, writing the electronic configuration, finding out the number of electrons in bonding, then anti-bonding, subtracting, dividing by 2. So what is the trick to do that quickly? Well, the trick is this diagram over here. What does this diagram explain? Well, let us understand. Here we have two triangles which are similar to each other and there is one big triangle. Okay, so let us make this triangle first of all. How I have made that. This is the baseline. We will be starting with 0, 0, then 1, and then 2 is going to be the tip of the triangle. In front of 1, just make a ladder and the 3 is in opposite to that, and 4 again touches the baseline. Then 5, 6, 7, 8, just similar to the first triangle. Next we have is 8, going up to 14. Make some ladders again for 9, 10, 11, 12, 13, and on the opposite end of the ladder we will be having 15, 16, 17, 18, 19 touching back on the baseline at 20. Right? I think this is easy. Now what are these numbers? That is what you have to understand. Well, these are the numbers of the electrons which are going to be in the molecules. Now why I have written 0 to 20? Well, this is because according to your curriculum, what we have learned is the homonuclear diatomic molecules and that also up till the second period elements. So neon is ending the second period, that is having the atomic number 10. So the number of electrons is 10. So Ne2 would be 20. So this means that we need up till 20 the number of electrons in our molecules. So that is why we have these till 20 over here. Now we have to calculate the bond order. Now every step start with the baseline at 0. Step number 1 is going to be 0.5. Add another 0.5 to go up to 2. Okay, so this is going to be bond order of 1. Come back to 3 minus 0.5. So 1 minus 0.5 we will be getting 0.5. Again coming down more further to 4 on the baseline, this is going to be 0. Okay, so we are adding from the baseline going up to the next number 0.5, and when we have reached the peak, then we have started subtracting 0.5 back again. Similar is going to be from 4 to 6 to 8. So 4 is going to be 0, 5 is going to have a bond order of 0.5, 6 number of electrons in the molecule, bond order is going to be 1. Then for 7 number of electrons, 0.5, and for 8 it is going to be 0. You can check the molecules that you have already learned. You will be getting these bond orders. Next we have is 9. So 9 is going to be 0.5, 10 will be 1, 11, 1.5, 2, 2.5, going up to 14 number of electrons with the bond order 3. So I hope you can remember now that nitrogen we calculated has 14 electrons. So 7 plus 7 was 14 and we calculated that the bond order was 3, and this is the maximum bond order we have. Okay, so next going back to 15, 16, 17, 18, 19, 20, just keep on subtracting 0.5 back again. So this is how we have the bond order pattern. So if the number of electrons for the molecule is 14, the bond order is 3. minus one number of electrons or plus one number of electrons, you will be getting bond order as 2.5. Minus another electron, another adding of an electron. So this is going to have a bond order of 2 and so on. So this chart, if it is into your mind, you will be able to find out the bond order of any molecule or polyatomic ion very easily. Okay. Now, remember one thing very importantly, that a zero bond order means that the molecule is not going to exist. Now, let us see an example over here. We have to find out the bond order for N2, N2 plus and N2 negative. So, N2 you will be finding out the number of electrons. This is going to be 14. So, the bond order is going to be 3. For N2 plus, the number of electrons is 13. Just check over here, it is 2.5. And N2 negative, the bond order is going to be again 2.5 because this is just one electron more than 14. So for one electron less or more than 14, the bond order is going to be the same 2.5. Okay, I hope you can understand this. Now let us move on to another example, O2. So O2 has 16 electrons. So this is how many more than 14? It is 2 more than 14. So 2 into 0.5. 2 into 0.5 is going to be 1. So from 3, just simply subtract that 1. So you will be getting the bond order as 2, and you know that between the two oxygen atoms we have a double bond and the bond order is 2, right? Then we have O2 2 negative. So this means 16 and 2 negative is going to be adding of 2 electrons. So 18 is the number of electrons. And now if you see over here, this is going to be 1. And if you think about it only, you're not going to draw this diagram over there as well in your examination. That will also take some time. So 14, and this is 4 more than that. So just 4 into 0.5 is going to mean 2. So 3 minus 2 will give you 1. As simple as anything. So O2 plus, this means that this is going to be 15 electrons and the bond order is going to be 2.5. So if you are going to practice it well, you are going to become really perfect it, and it is not going to take even a fraction of a second for you to find out the bond order. The next trick we have is to find the magnetic behavior of the molecules. Now to find the magnetic behavior, what did we do? Well, we wrote down the electronic configuration. Then we saw whether there are any unpaired electrons present in the molecule. If there are unpaired electrons, it is paramagnetic. If there are no unpaired electrons, all of the electrons, they are paired up. That means the molecule is diamagnetic, right? This is what we do. No, we are not going to do that because we want to save time. But yes, even if you're having a subjective exam, you have to do that. There would be no shortcuts in a subjective exam. This is only the tricks for competitive exams where you have multiple choice questions and you have to do them in a very short time. So the number of electrons, then you are going to count for the molecule. If this comes up to even, the molecule is going to be diamagnetic. Well, if the number of electrons is going to be odd, the molecule is going to be paramagnetic. But wait a minute. Did I tell you that oxygen has 16 electrons and it is paramagnetic? Yes. So now I am saying that the number of electrons has to be odd for the molecule to be paramagnetic. Well, there are two exceptions that you have to remember for predicting the magnetic behavior. And those two exceptions are that if there are 10 electrons in the molecule or if there are 16 electrons in the molecule, these two molecules or the ions, they will be having a paramagnetic behavior. One thing why I'm saying is that ions and molecules over here is it is not only oxygen, it can be any ion or it can be any molecule which is having the number of electrons to be 10 or 16. Okay, so you will be just counting them, and for the bond order as well as the magnetic character, when we have the same isostructural species, the bond orders will be same and the diamagnetic and the paramagnetic behavior will be same. Okay. Now, let us see an example over here. We have N2. So, N2 has 14 electrons. This is an even number. So, the molecule is going to be diamagnetic. Next, we have N2 plus. So, N2 plus means that there is going to be loss of one electron. So, 13 electrons. And it is an odd number. So, it is going to be paramagnetic. Then we have N22 negative. So, N22 negative means nitrogen 14 and plus 2 for the gain of electrons. So this is going to be 16. Now 16 is the number, so you have to just think of this. This is not going to be diamagnetic. This is going to be paramagnetic, because these are the two exceptions that you have to remember. Otherwise, it is going to be very simple for you. Even is dia and odd is para, right? Now let us see a few examples based on our learning. Well, these examples which I have chosen, they are from the previous year JEE Advanced and IIT entrance examination questions from the past years, so that you can just have a glimpse of those questions, and you will realize that the questions, they are really easy once you know the concept, and these two tricks, they will be really helpful for you in solving the questions very quickly. So the first question we have is that which of the following have identical bond order, and this is a question which was asked for the IIT entrance exam in the year 1992, and the choices are Cn negative, O2 negative, NO positive and Cn positive. So here you are again going to remember that we will be calculating the total number of electrons, and all the isoelectronic species, they will be having same bond orders. So only the number of electrons and the corresponding bond order will give you the bond order for these ions as well. So Cn negative, number of electrons, carbon is 6, nitrogen is 7, minus 1 charge, so this means we will be adding one number of electrons, so 6 plus 7 plus 1 is 14, so the bond order simply is 3. Nothing to be done more about it. Well, O2 negative, so 16 plus 1 is going to be 17, bond order is going to be 1.5. How did I do that? Well, 14 was 3. We have jumped to 3 places, so 3 into 0.5 is 1.5. 3 minus 1.5 is going to give you 1.5 as the bond order. Simple. Next we have is NO positive. So the number of electron, nitrogen 7, 8 for oxygen, minus 1 for the positive charge, you will be getting 14 as the number of electrons, so bond order is 3. Cn positive, number of electrons 6 for carbon, 7 for nitrogen and minus 1 for the positive charge. So 12 number of electrons, the bond order is going to be 2. How did I do it? 14 minus 12, this is going to be 2 places of a jump. So 2 into 0.5 is 1. So 3 minus 1 is going to give you the bond order of 2. So I think this is easy, and well, you can do that in a fraction of a second now. So now the next answer, well, the answer over here, yes, this was A and C, because we wanted to have an identical bond order, and the choices A and C, they have identical bond order. The next question we have is, among the following, the paramagnetic compound is what you have to find out. So here we have Na2O2, O3, N2O and KO2. So what are we going to do? We are going to simply total the number of electrons and see whether the number is going to be even or odd, with the exception of 10 and 16, where they are going to be paramagnetic. Okay, so this question, this was asked for the IIT entrance exam in the year 2007. Now let us quickly do that. So Na2O2, when you are going to total the number of electrons, this is going to come up to 32, and 32 is an even number, so this is going to be diamagnetic. O3, the number is going to come up to 24, again even, so diamagnetic. N2O, this is number is coming up to 22, even again, and diamagnetic. So the last choice left, obviously that would be paramagnetic, but let us check that also. So KO2, when you're going to total, the number is going to come up to 35. And yes, this is odd, so this is going to be a paramagnetic compound. So I hope the things are now relatively easy for you people. Next, let us see another question, and this is the question which was asked on the IIT entrance exam in the year 2004. According to MOT, O2 positive is paramagnetic and bond order should be greater than O2. Well, then it should be O2 positive is paramagnetic and bond order less than O2. O2 positive is diamagnetic and bond order is less than O2, or O2 positive is diamagnetic and the bond order is greater than O2. So what have we to do? We have to find out the number of electrons. So O2, this is going to have 16 electrons, and 16 electrons is the exception for the paramagnetic behavior. It is an even number, but it is going to be paramagnetic, and if you have to calculate the bond order, this is going to be 2. For O2 positive, this is going to be 15 electrons. It is an odd number, and this is therefore going to be paramagnetic with the bond order of 2.5. So I think you are now able to tell The answer is going to be A, because O2 positive is paramagnetic and the bond order for O2 positive is greater than that of O2. I hope this is clear perfectly well. Very simple questions asked in the IIT examination. Next we have the fourth question. According to MOT, C22 negative is expected to be diamagnetic. O22 positive is expected to have longer bond length than O2. N2 positive and N2 negative, they have the same bond order, and He2 positive has the same energy as the two isolated helium atoms, and this is a relatively recent question, JEE Advanced 2016, and you will be able to crack it very easily. So just pause and find out the answer yourself before listening to the solution now. Now, if you have done that, well, let us check it quickly. So, C2 negative, we are going to 2 negative. So, number of electrons is going to be 12 plus 2, 14. Even number, so this is going to be diamagnetic. So, this choice is correct. Well, this is going to be a multi-correct answer question, which I forgot to tell you earlier. So, O22 positive, this is going to have number of electrons to be 14 and the bond order is going to be 3. Now, when the bond order is 3, the number of oxygen atoms, the number of electrons is 16, the bond order is 2. So which has a higher bond order? Well, O2 positive has a higher bond order, and the bond order, this is inversely proportional to bond length. So the bond length of O2 is going to be longer than O2 plus. What do we expect? Well, is it right? So no, this choice is going to be incorrect. Next, we have N2 positive and N2 negative. So the number of electrons for N2 positive is going to be 13. The bond order is going to come up to 2.5. And N2 negative, this will be having 15 electrons. Again, the bond order is 2.5. So both of them, they are having the same bond order. So this choice is also correct. Next we have is He2 positive. The number of electrons are going to be 4 minus 1, 3. The electronic configuration is going to be sigma 1 is sigma 1 is 2, sigma star 1 is 1. So this means the number of electrons in the bonding orbitals is more than the number of electrons in the anti-bonding orbitals, and therefore what we will be seeing is that the number of attractive forces over here are going to be more. Hence, the He2 positive ion, this will be having lower energy than the two isolated helium atoms. Okay, so this choice is also going to be incorrect. So what are the correct choices? A and C. Now, the last question that I have for today is, well, this is not something that is in relation to the tricks that you have learned today, but this is something that we learned in the last lecture. Assuming 2s2p mixing is not operative, the paramagnetic species among the following is. So this is something that I have been telling you in the last lecture. So this is very important so that you do not forget it, you do not commit any mistake in the examination. I put this question as well. So this question, the choices are BE2, B2, C2 and N2, and this is the question which was asked in JEE Advanced 2014. Now, if we have beryllium first, the electronic configuration for the atom is 1s2, 2s2, and if you write that for the molecule, it is going to be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So here there is no choice where we have a 2s2p mixing, because the orbital are not having the electrons in the 2p orbitals. Okay, so there will be no 2s2p mixing for the Be2 molecule. Then we move on to the boron atom. So here the electronic configuration is 1s2, 2s2, 2p1, and for the molecule we will be having sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 and pi 2p1. Okay. So here, yes, we do have 2s and 2p orbitals, but what we are seeing over here is, had this been not an sp mixing, okay, so had this not been an sp mixing, what would have we put here over here? We would have put over here a sigma, right? So that would be a sigma 2p1. But in either of the case, whether we have an electron in pi 2p1 or we have it in a sigma 2p1, the species would have been paramagnetic, so there would have been no change. Right. Next we have is the C2 molecule. So for the C2 molecule, the number of electrons is going to be 12. And again, if you write the order which you have learned according to the SP mixing, it would have been sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then pi 2p x2, pi 2p y2. And according to this, it would have been diamagnetic, right? But now, if the SP mixing is not operative, then what would have been the electronic configuration? The electronic configuration would have sigma 2p z2 filling prior to. Okay, the pi to p x, pi to p 1. So we would have written the electronic configuration as sigma 2p z2, pi to p x1 and pi to p 1 to be making it a 12 electrons. Now if you see over here, we have two unpaired electrons and the molecule has become a paramagnetic species. Okay, so this is the answer that is going to be, but let us look at N2 as well. So in case of N2, what you will be seeing is that pi orbitals as well as the sigma orbitals, they are all going to be filled. So either if you put it over here or you have put it at the back, it is going to remain the same. So this species would remain diamagnetic. But I hope you understand that whenever SP mixing is mentioned that this is not operative, you have to do the first filling in sigma 2pz. Okay, I hope this is clear to people. Now I'm going to give you a few orders which are frequently asked in the examination. So the first I have is the relative order of stability of nitrogen and its ions. So the order is that N2 is the most stable, then N2 positive, then N2 negative, and the least stable is N2 negative. So what you have to remember over here is that the order of stability is going to be directly proportional to the bond order. More is going to be the bond order, more is going to be the stability. So N2 with the bond order of 3 is going to be more stable. Then N22 positive and N22 negative, they will be having a bond order of 2.5. But N22 positive is more stable than N22 negative, because here if you are going to write the electronic configuration, you will see that there is an electron in the anti-bonding molecular orbital, making N2 negative less stable than N2 positive. Okay. And N2 negative, this is going to be the least stable with the bond order of 2. Next we have is the bond length comparison. So bond length, this is inversely proportional to the bond order. The bond lengths therefore will be of the order N2 being the shortest bond length, then N2 positive and N2 negative being equal because they have the same order of 2.5, and N2 negative, this is having the longest bond length because the bond order was 2 and that was the least from these all. Okay. Next, let us see for oxygen and its ions. So again, the trend is going to be the same. More is going to be the bond order, shorter is going to be the bond length. So you are going to get this order this way: O2 negative, this will be the longest bond length, then O2 negative, then O2, and then O2 positive. Now is the bond dissociation energy. So this can also be asked. So the dissociation energy that we have studied, more is going to be the bond order, more is going to be the bond dissociation energy, because more number of bonds have to be broken, so more energy is required. So the order is going to be just reverse of the bond length. So O2 negative, this is going to require the least bond dissociation energy, and O2 positive will be requiring the maximum. Now the isoelectronic species, please remember they have the same shape and same bond order. For example, carbon monoxide and NO positive, they have the same bond order of 3, and the number of electrons, when you will be calculating, this will be coming up to 14, which is equal to the number of electrons in the nitrogen molecule that we have studied. So I hope you have understood the whole concept very well now. So that would be all for this lecture, and in the next lecture we would be talking about hydrogen bonding, and then this is going to be the last concluding lecture for this course of chemical bonding. And well, please do subscribe to the channel H2, because now the next new courses, they are going to come up for you and you would not want to miss them, when we have made all the courses in such a detailed manner that you do not miss a single concept. I hope you will be subscribing to the channel, and also do click on the bell icon so that you get the notification the moment we put up the new lecture for you. Any doubts from this course, this lecture, or anything from chemistry for class 11 and class 12, please feel free, mail us at h2chemistry@gmail.com. Also, you can put your doubts in the comment section. You can join us on Facebook with the same name, H2 Chemistry, on the Facebook also. So see you again. Have a nice day. God bless you.